Okay, welcome everyone. Huh? Better. Yeah, cool. Welcome everyone. My name is Adrian Blumer. I'm from the Esri R&D office in Zurich, in Switzerland, where I work on the 3D part of the JavaScript API. And today I will tell you a little bit about how you can control the environment, the lighting, as well as performance options in the scene to optimize the visualization of your data. I'll go through various options that we offer, show you how they influence the visualization, and all the settings that you can pick. So we'll first start with a look at time and date, because basically the lighting, as we have it set up in our scene, is influenced or depends on the current time and date settings. The same goes for stars, then, well, light and the shadows it causes, which, if configured correctly, help you or your users with the perception of 3D features. We'll also have a quick look at atmosphere rendering and how that helps you with depth perception, for example. Next up, quality profiles, which basically give you an option to switch between performance and visual quality, or to tweak this trade-off. And finally, under this esoteric name of the road to enlightenment, I'll give you a small sneak peek at a feature that is currently in development and hopefully will find its way into a future release, which covers a few, which is based on feedback that we got from our users in terms of lighting and presentation of data, but more on that later. So to get started, basically, the code snippet you see here on the right side, sorry, this is just the basic setup that we will work from in all of our examples going on from here. We start creating a map, add a simple base map to it, ground elevation, and then create a scene view from it, possibly set the camera to a specific position that will help us to make the point that I try to bring across. So let's have a look at time and date. First of all, might feel, or it's pretty clear that the sunlight depends on the current time and date. So if we change time and date, as we can do here by animating, it will move around. The other thing, however, which might be confusing at first, is that by default, the current lighting or how you orient your camera actually influences the time and date settings of the lighting. So if we look at a scene like this, and we look at the time and date, we see here that the lighting is based on this time and date object. Now, if we rotate around, this is the default behavior in the API. It will always adjust the current time and date such that the lighting stays constant for the changing view. So if we look up the date again, move a little bit, check again, you will notice over here that this is changing. Now, this behavior you can easily deactivate by accessing the lighting property on your view. This is under View Environment Lighting, and has an attribute camera tracking enabled. So with this code snippet here, we'll quickly toggle this, and if you move now, you'll see that lighting stays constant and time and date do so as well. If we were to decide to stay at this state and enable camera tracking again, you'll see that camera tracking doesn't guarantee that your scene is properly lit. It just guarantees that the lighting stays constant. We can obviously also, by setting view environment lighting date to just the current date, update this. Oh, sorry. Probably don't want camera tracking for that. But you'll see that here, North America, we're still in daylight, whereas Europe, where I'm from, for them, it's night currently. Now, as I mentioned, this can also be animated over time, which we basically do by requesting an animation frame, and every time we get it, we access the current date set on the lighting, update it in a time-lapse manner, updating a couple of seconds every few milliseconds, and then specifically assign it again to the date. Now, the reason why we can't just directly modify the date object here is that there is some update magic going on behind the scenes here, and the explicit assignment tells our scene view that the current date has changed. Now on to a look at the stars. As I mentioned earlier, let's give this a moment while I guess it's loading. But yeah, as I mentioned earlier, the stars in our scene view are also influenced by the time and date. So we're not just rendering random dots of various brightness in the sky for you, but we're actually rendering the correct star positions and brightnesses based on the date and time that you specify, which allows for some cool, okay, I have to double check if something. Okay, there we go. Sorry about that, which allows some cool options. First of all, for your use case, stars might just be visual clutter. So we offer an option to simply deactivate them. Again, defined on the environment, stars enabled. But if you decide to stick with stars, this allows us the option to, if we know when and where to look, to actually find star constellations. Now, I'm not sure how familiar you are with them. This is probably the one star constellation that I know in the sky, which is like the Big Dipper or Ursa Major. And you also find it on the flag of Alaska. It's basically this constellation here to the left, and you see it here and continuing to here. Now, one more piece of random knowledge is that if you follow this edge here up, you'll actually end up at the North Star or Polaris. And we can do that here. And here in the center of the view, we have now Polaris. Polaris is a nice property in the night sky, which is that over time, it stays stable in its position. So if you have like these long exposure photographies that you might have seen, usually Polaris is like the center that stays stable with circles around it. Anyway, that's it about stars. On to light and shadows. Here we are looking at a scene, at a mesh scene layer of Zurich, visualizing all the buildings in Zurich. And what you see here is that this scene is lit by two light sources. There is the sunlight, which is a directional light source, currently like coming from up here probably. And as a directional light source, the intensity of how much it affects faces on your geometry depends on, well, on the angle between your surface and the light direction. This is why here in the back we don't have any lighting on the surface, and the more a surface faces the sunlight, the brighter it gets. There's, however, a second light source in this scene, which we call an environment light. The environment light is the reason why here in the back of the object of this building, which is not facing the sun, why it's not completely dark. The environment light basically is a light source that lights everything evenly from every direction. It just helps you to get an overall brightness into the scene. Both of these light sources are completely set by the date and time. But, I'm jumping ahead. So first, one option that you have to influence the direct lighting is that by default, here you see this part of the building is somehow lit, even though there's other parts of the building in the way between it and should occlude the sunlight. To properly simulate this, we need direct shadows, which you can enable on the environment lighting. If I do this, you see here now that all our objects in the 3D scene cast shadows on themselves, on other buildings, on other objects, as well as on the base map terrain. The problem, however, is that if you look at these parts of the building, even though, yeah, you can guess that these are like two different faces at a right angle, but it's difficult to actually make out this difference, or even here, the corner. The problem is basically, as I said, that this environment lighting that is influencing the scene here has no directionality. And thus we can't like compute any shadows for it. There's an approximation, however, which is ambient occlusion, which basically assumes, hey, which parts of the geometry are like narrowed together and tries to approximate the fact that less light will actually reach these parts. And as you can see, this clearly helps your 3D objects to have a more, well, 3D plastic feel in the scene. It should be noted, however, that both of these features, the ambient occlusion as well as the direct shadows, do not come completely free, so they might come at a performance overhead. So depending on how powerful your target devices are or how complex your scene, well, you have to evaluate it for your use case. Now with this in place, with the shadows in place, it's also easier to see like what direction the sun actually shines from. And now I can go back to animating the lighting over time, and we'll see how the shadows wander during the day, become longer as the sun moves through the sky. However, if we end up at night and deactivate ambient occlusion again, we see one shortcoming of this, which is now the sun is basically behind the Earth, the body of the Earth. So there's only ambient light, which is really low at night here, and we can't really make out anything. This is a limitation in the current API, and in the sneak peek at the end of the presentation, I'll show you some work that goes into improving this situation. Also, the other thing that we see here, let me animate this again, is that that the base map and the objects are not shaded consistently. So while the color of the sunlight changes throughout the day and influences the color of the final buildings, the base map is always appearing the same. Again, keep this in mind for the final demo. Next, on to atmosphere. So what we are looking at here is actually a part of the Swiss Alps, a very mountainous region, but it's really difficult to actually tell so. We don't have, the base map here doesn't have any pre-rendered shading and gives us very little depth cues. Now this is where, for example, the atmosphere setting comes into play. The atmosphere can be set at 3 different settings. You can completely disable it, like this. You can set it to low, which is the default, or you can activate it and set it to high, which, well, the difference is striking. Basically helps you a lot with depth cues. What we do if you set atmosphere quality to high is we do a simulation of the fact that you have dust particles in the air, basically here between your terrain and your camera or your eye point. And the further away you get, the more dust particles there are, and leading to this very, depending on the situation, really useful depth cue. Overall, the atmosphere setting influences 3 parts of the scene. The appearance of the sky here, as we saw, yes, disabling it completely only shows us bare space. It also influences how the horizon might look like, and then the air between, well, your ground and the camera. All of these three settings also influence the overall look of the globe if you zoom out to a more global scale. As you can see here, again, this is where like the horizon comes really into play. You can completely disable it, which actually gives it a really clean look, or activate the basic atmosphere, which helps shaping the sphere as the Earth as a sphere, or go for realistic, as in this example here. Now let's go back to the mountain setup. And if I go to low atmosphere setting, again, the high quality atmosphere comes with a performance impact. That's just how it is. Just to make things clear, sometimes it's enough to just switch to a different base map. For example, this one here has like pre-baked lighting on it, which already helps as well with the depth perception, or maybe just switch to a satellite map. It really depends on your use case. But just to have a fair comparison, I think we should mention this. But still, if we look at the high quality atmosphere and animate over time, You also see that one difference is that the high quality atmosphere also like simulates the sun body in the sky, and over time, there we go. Over time, the shading of these dust particles in the air changes and so on. And it just overall, also like the lighting in the night hours is computed in a more realistic way actually. Okay. Then quality profile. This is technically not a part of the environment, but still it fits very well in this context because it can significantly influence how your data is presented to the user. So first of all the settings you saw so far, you can change them on the fly while displaying your scene view at any point in time. Whereas the quality profile, ideally, you set it when creating the scene view once and for all. This is due to some hardware limitations, but yeah, usually you don't want to change it too often, or just create a new scene view if you really have to. So there's two values for the quality, low and high, and usually we just set a reasonable default based on our experience with devices and browsers, which is basically if the user is visiting your site using Internet Explorer or Safari, we default to low, because these browsers are, well, in our experience, known to have performance problems, and in all others, we default to high. This setting influences mostly three things in your scene. The number of map tiles that are rendered increases in high relative to low. The scene layer detail level, so scene layers based on the current view and the distance of individual parts of the scene to your view choose a level of detail level. And in general, in low, they will earlier pick a lower level of detail level. You'll see this in a second. The last one is anti-aliasing quality. So if anti-aliasing doesn't say you anything, this is basically about smoothing the edges of your geometry. Again, you'll see this in the live example on the next slide. However, it might be difficult to see just on a beamer here, so I created these two cutouts with some magnification. It's mostly apparent at geometric edges where you have high contrast, and you see on the left without any edge smoothing, and on the right with edge smoothing applied. Okay, now for a side-to-side comparison. Here, once it loads, we have two scene views synced to each other, and with some debug visualization active in the form of these red lines. You'll see more of these in a second. On the left, low quality, on the right, high quality. So one thing that stands out, or if you look closely, is in this region here, we see that the scene layer picks a low level of detail, whereas here it already chooses to display the higher level of detail level. I'm not sure whether you can make out on this beamer screen any difference in edge quality. Maybe here, like at these high contrast edges, it might be a little more, well, you might make out steps, or maybe if I move the camera, but probably not. So the other thing about the number of tiles rendered, for that I'll zoom out, and you basically see that in high quality mode, we continue subdividing tiles to a higher level of detail, and this can affect performance quite a lot, just the sheer number of these geometry tiles that are rendered, especially if you consider a use case where you look far into the distance. This easily becomes a lot more, which can highly influence your performance. Okay, and that brings me to the last slide, or last demo slide at the very least. So this is all about a project that I've been working on earlier this year, which is following user feedback. A couple of things in terms of user feedback reached us. One is that people would like to kind of disable the sun, so they don't want that half of the Earth at any time is unlit, which is particularly a problem near the poles, where it's difficult to just get even lighting. So if you're I'm not sure if you work with polar bear observation data or whatever at the North Pole, you might be affected by this. The other thing is, I tried to point this out earlier, is that parts of the scene that are not very lit can make it difficult. Sorry, 1 second. There we go, much easier. Make it difficult to differentiate certain faces. So what we went for here is, instead of going with like, hey, try to mimic reality, try to simulate the sun, rather try to mimic a photo studio, try to simulate studio lighting. And I'll walk you through now the individual steps that make up the lighting in this scene. So first of all, we'll just turn off everything. So now, one thing that we added here is that the base map, the terrain, and the 3D objects in the scene receive exactly the same lighting. Overall, this makes for a more consistent look of your scene. But also it means that if there's no light active in the scene, well, everything is black. So let's turn on the ambient lighting. What you see here is what I mentioned earlier. Ambient lighting doesn't help you to figure out what direction your geometry is facing or anything. It just comes the same amount from every direction and just overall gives you some information about the scene. This is why we turn on the main light. Now the main light is really similar to sunlight, but we're not calling it sunlight because it really doesn't behave in terms of date and time dependency. This already makes everything look significantly better. In this scenario, this main light comes from the lower left, and if we look at a 3D object in the scene, we again see the point that I made earlier, where it's difficult to make out the difference here. This is why we introduce fill lights. Really, as in a photo studio, you want to light your subject from the side, maybe. In this case, let's add a red fill light from the side. And you see that this, I hope you can make it out on the beamer, that this face is now slightly lit red from the side. This face, on the other hand, is not lit at all. So let's add a second fill light, this time a blue one. And if we zoom out, you'll see that this is really not just like an operation on your individual scene objects, but on the whole rendering in total. Obviously now you don't want this much blue and red in your scene. So we can tune down these two lights to a more subtle bluish and reddish tint. Now let's see whether maybe you can make it out on this screen, maybe not, but now the object is lit slightly reddish from one side and slightly bluish from the other. This really, like, while still keeping the fact that this is actually not facing the main light source, this helps the user to like distinguish these two faces subtly. Next, there were also user requests that would have liked to influence the background of the scene, basically all you see around here of the globe. So we introduced this. Maybe you want a completely white background. Maybe that's like too bright for you and you want to go with something bluish that fits my slide design here or whatever design you have on your web page. Or for now, we'll just stick with this light blue-gray that is more subtle and fits the overall look of the scene. Now, the last thing to show off here is that there actually have been requests of, hey, I would like to do this Instagram thing to my scene view. So we also experimented with this. And for this, let's quickly first switch to a more colorful base map to make a better point. And we added, just as an experiment for now, some filters that you can apply to this scene. So basically, you can change the contrast in the scene, increase it, or even further increase it. And again, it influences the whole appearance of your scene. This is probably too much, but just, again, to make a point. Let's switch back to the normal contrast. We can do the same for saturation. So maybe you want to reduce the saturation in your scene to not distract from other content that you display besides the 3D view. Like you can actually get completely rid of any color in the scene if you want. And for now, again, let's go back. And if you're, for whatever reason, want to go full Candyland, well, that's possible too. So the main points here are that we're trying to give you the option to have more functional instead of realistic lighting, to give you the option to just tweak the overall look of your scene and the background as well. And yeah, this is, however, disclaimer, this is still a work in progress, so we'll see how much of it or with what API exposed this will appear in future API releases. And that's it from my side. Yeah, open for questions. Thank you very much. Also, we were told that we should show you this slide about talk feedback. So for me personally, this has been my first talk as an Esri employee at any of their conferences. So yeah, any feedback really useful. You can go through the app, you can just come up to me, let me know. Or also if you have questions that you don't want to ask here in the plenary, I'm up here, I'll be later at the islands. Yeah. Thank you for your attention.